Hey guys, welcome to yet another video. This is Harsh, and today we are going to talk about seasonality and also explore how we can plot seasonal patterns in Python as well as Excel. So let's get started. So firstly, let's understand what seasonality really is. As the name suggests, this is a phenomena where patterns are observed to repeat themselves year on year. As you may see in the case of ice cream sales, usually the sales are higher during the summer months and fall during December as it is winter during that time. Similarly, with crackers, sales are usually high during the Diwali season. So, in similarly, we what we have done over here is we have taken the monthly sales of a publicly listed company, Varun Beverages Limited. So we have taken the data from Jan 2015 to December 2025, and we are going to analyze and break down the sales into a long-term trend, seasonality, and noise. So these are the three components that we'll be breaking down the sales into. Let's explore each one by one. So first let's understand how I have calculated the long-term trend. I have taken the simple 12-month moving average and I've started from the month of June. So this is called a centered moving average. Let's say if I had started from the month of December, it would have been called a trailing moving average. But in case of time series decomposition, we always use a centered moving average. That's the practice. I'm not entirely sure of the reason, but this is the way it works. So I've just calculated the 12-month rolling average and I've just dragged down the formula till the very end. And you might notice that these rows are blank. That is because if let's say I were to drag down the data over here, then this would again extend to this row as well, which is empty. So that's why I've left these rows as blank. That doesn't affect our analysis per se by a lot. And so this is the long-term trend, and I've plotted the long-term trend on this graph, which you can see is an increasing trend. So why do we plot the long-term trend? It's just to, have a glimpse of how the overall sales are performing year on year. So we see that this is an increasing trend. We want to make the trend as smooth as possible. Okay, we want to remove all the fluctuations from it. So let's talk about seasonality over here. First, I have taken the difference between the long-term trend and the observation. So if you look at this row, 118 is simply the difference of C7 and D7, 892 crores minus 775 crores. And will the seasonality for the June month is coming to 246. Now, how did I get to this number? So what I basically do is I take the difference between the revenue and the long-term trend for all the months. Okay. And now let's say I want to find the seasonality in June. What I will do is I will take the average of this difference only for the June month for all the years till 2025. Okay. Similarly, I'll repeat it for July as well and for all the subsequent months also. So if you see, I have dragged down the seasonality formula till row 18. Okay, because from row 19 we have again reached June and we have already calculated seasonality for June. Okay, so basically you need to drag the formula from row number 7 till row number 18 once, and then you can simply use a VLOOKUP because the seasonality values will be the same. We have already calculated seasonality for the month of June. There's no point in calculating it again. It remains the same. So these values just, they just repeat themselves throughout. And that's how we then get this graph over here. We just simply plot all of these values, seasonality graph. So what can we infer from this graph? Let's check. So if we look at the seasonality plot over here, in the month of May, the value is a positive 307 crores. So what does this mean? This simply means that Varun Beverages Limited will sell 307 crores more than its long-term average sales. Okay, the long-term trend which we had calculated already over here, it is more likely to sell 307 crores extra during the month of May, which is a summer month. And this is intuitive, right? Because this is a company which supplies, bottles to, it's a bottling company, so it supplies bottles to all the major beverage makers in India. And given that it's summer, beverages will sell more, and thus more bottles will have to be supplied. And that's what it implies over here as well, right? And similarly, if we go to December again, intuitive, right? Minus 385 crores. What does this mean? That the company will be selling 385 crores lower than the long term average during the month of December, because it's winter and usually beverages and ice creams sell less during this point. So let's say I'm the production manager at Varun Beverages Limited and it's the month of May. So I know that sales will be likely on the higher side. So I'll have to decide in advance as to, how many additional machines would need to be installed, how much labor to recruit, do we need additional raw materials. So, and I can make an estimate that, okay, it's May, peak summer, so we'll be selling around 307 crores higher than the average that we used to sell, right? And similarly during December, if it's, let's say it's December, then I can cut costs, because what I'm assuming is usually the sales will be lower by around 385 crores than the average, right? So this is how people make rough estimates about when seasons come and go. And obviously, see, these are not accurate to the cent, right? And for that we have plotted this error term, to which we'll be going next. So coming to the computation of the noise component, the noise component is computed as C7 minus D7 plus F7, which is nothing but the actual revenue minus the long term trend plus the seasonality. Okay. Now we live in an uncertain world, right? So you can't predict anything uh, with 100% accuracy. So from this graph, what can we infer from this graph? So let's say I come to August 2019 and the value is a plus 17 crores over here. Okay. Now what I'll do, I'll go to August 2000. This was August 2019, right? Yup, value is 17 CR. So I'll simply go and check August 2019 here as well. And the value is 25 crores over here. So what does this mean? So according to my seasonality trends, I thought that it's August and generally we are expecting 25 crores higher than average sales during this month. So let's ramp up our manufacturing facility around that, and I prepare for 25 crores of extra sales. And then what I get as a surprise or a shock, you can say it anything, okay, anything you like, is an addition of 17 crores of sales. That means the actual sales came out to be 25 plus 17, which is 42 crores. Now you might say that's a big number. No, that is not a big number. That's not a big error when the total sales of these companies is in the range of thousands of crores. A 10-20 crore number is not a big deal. So if you see this particular range, no, you can see the error term is very low. Means our seasonality is almost predicting the exact sales that will happen during this particular month. Okay, error is nothing but the residual, right? So because see, if you were to compute this long, I can get back this number from these three components. How? Simple. Long term trend, my plus the seasonality plus the noise. And you see this is 893, 892, and then drag back, I'll drag this down and it's matching, right? So the revenue is made up of three things. It's made of the long term trend, it's made of the seasonality, and it's made of the noise. Now if you see over here, we have the noise as only 3 crores over here. We know the long term trend and we have already predicted the seasonality, right? So in this month, the in July 2015, you see how near are we to the actual sales, right? It's 872 crores and we predicted almost 869 crores, right? Only 3 crores was an error over here. Of course, there are times when the error terms were quite high, but again, so we live in an uncertain world, right? No one can control the macro environment as such. What we can do is provide an estimate, provide a best estimate, and you have to adjust for standard deviations. Okay, those are part of the game. So this is the whole idea of how you use seasonality and long-term trend and the noise and how they fit together in one picture. So the computation need not be so intensive. What I've done in Excel, there's a simple Python code that you can use to generate all of this, which I'll be showing right away. So let's see the Python code as to how the same thing could be done in Python with much less effort. So I've imported some packages over here: pandas, matplotlib, and stats models. And then you need to use the pandas library and apply these particular functions. First, we'll be reading from this particular CSV file. This is VB monthly sales. It's the same file as what I showed you previously, and we are going to set the index to the month column. In the month column, all the dates were present, so that will be set as the index. And then we are going to apply this function seasonal decompose, and this is just the size of the figure, and then we'll simply run the program. And so you can look up all of this online, and you can just do chat gpt and you'll get all of this online. So it's a pretty simple process. So if I run this, and let's see what I get over here. Yup, there you go. So what I can see over here, this is almost the same figure that we got in this Excel, right? So if you see, let's just compare it with what we got in our Excel as well. It's not showing me those graphs over here. Yeah, there you are. So if you look at the seasonality graphs, they are exactly matching, exactly tying out. The long-term trend is also similar. There might be minor differences, but who cares about those? And the error term, this is in the form of dots, and here we have lines. Okay, so you can do the same exercise in Python as well. And this is it. Thank you so much for watching this video. Do like and subscribe to the channel, and see you next time.